C is a powerful and versatile programming language. It has been the backbone of many software applications and systems we use today. Created in the early 1970s by Dennis Ritchie at Bell Labs, C has become a cornerstone of modern computing. Its influence is seen in many of the technologies that have shaped the digital age. It's known for its efficiency, speed, and close to the hardware capabilities. This means that C allows programmers to write code that can directly interact with the hardware, making it ideal for system-level programming. Learning C is like learning the fundamental principles of how software interacts with hardware. It provides a deep understanding of how computers work at a low level, which is essential for any serious programmer. C is often considered a middle-level language. This means it combines the features of both high-level and low-level languages, offering a balance between ease of use and control over hardware. It bridges the gap between high-level languages like Python, which are easier to write and understand, and low-level machine code, which is more efficient but harder to work with. This makes C suitable for a wide range of applications, from operating systems to embedded systems. Its versatility means it can be used for developing software that requires high performance and efficiency. Despite its age, C remains highly relevant today. Many modern programming languages and systems are built on the principles and syntax of C. It forms the foundation for many other programming languages, including C++, Java, and C#. Understanding C gives you a deeper insight into how these languages work and how they have evolved. Understanding C gives you a deeper insight into how these languages work. It also helps you appreciate the design and structure of modern software. Learning C can be challenging, but it's incredibly rewarding. The skills you gain from mastering C will serve you well in your programming career, providing a strong foundation for learning other languages and technologies. It teaches you to think like a programmer and solve problems efficiently. You'll learn to write code that is both effective and optimized, a skill that is highly valued in the tech industry. With dedication and practice, you can master the fundamentals of C and unlock a world of possibilities in software development. Whether you're developing software for embedded systems, operating systems, or high-performance applications, C provides the tools and knowledge you need to succeed. Every C program follows a specific structure. Let's break down a simple Hello World program to understand the basics. Hash include int main. The first line brings in a library of functions for input and output operations. The function we use later comes from this library. The line defines the starting point of your program. The code within the curly braces is what gets executed. Tells the computer to print the text Hello World to the screen. At the end is a new line character, ensuring the next output starts on a new line. Finally, signals that the program ran successfully. This simple structure forms the basis of every C program you'll write. C provides various data types to represent different kinds of information. Here are some fundamental ones. You declare variables in C by specifying the data type followed by the variable name int age =25, float price $19.99, char grade $A. Understanding data types is crucial for writing programs that handle information correctly. Pointers are a fundamental concept in C. They are one of the most powerful features of the language, allowing programmers to directly interact with memory. They allow you to work directly with memory addresses, which is essential for tasks like dynamic memory allocation and manipulating data structures. This direct access to memory can lead to more efficient and faster code. A pointer is a variable that stores the memory address of another variable. This means that instead of holding a data value, it holds the location where the data is stored. You declare a pointer using the asterisk symbol. For example, int *PTR, this declares PTR as a pointer to an integer. It tells the compiler that PTR will hold the address of an integer variable. To get the address of a variable, you use the ampersand AND operator. For instance, if you have an integer variable named num, you can get its address by writing a num int num =, 10, petar =, hash. Now petar holds the memory address of the variable num. This means PTR points to the location in memory where num is stored. To access the value stored at that address, you dereference the pointer using the asterisk again. This means you are telling the program to go to the address stored in the pointer and retrieve the value there. printf %ddn PTR gives you the value stored at the address PTR is pointing to, which is the value of num. Pointers might seem complex at first, but mastering them is key to unlocking the full potential of C. They provide a level of control and efficiency that is unmatched by other features in the language. Understanding pointers will not only make you a better C programmer, but also give you insights into how memory and data structures work at a low level. Section 5. Flow control directing the program. Flow control statements determine the order in which instructions are executed in your program. Allow you to execute different blocks of code based on a condition. For example, in C, if age = 18, print if you're eligible to vote, N, else print you are not yet eligible to vote, N. Repeat a block of code a specific number of times. Here's a simple example. For int I = 0, I5, I++, printf, %dni // print 0, 1, 2, 3, 4. Repeat a block of code as long as a condition is true, like this. Int count = 0, while count 10. Printf %dn count++. Flow control gives you the power to create programs that can respond to different situations and perform complex logic. Section 6. Functions, organizing your code. Functions are reusable blocks of code that perform specific tasks. They help break down your program into smaller, manageable parts, making it more organized and easier to maintain. Here's a simple function that adds two numbers. Int add int a, int b, return a plus b. This function takes two integers as input and returns their sum. You can call this function from your function int result = add 5, 3. Printf, the sum is %ddn result. Functions promote code reusability and make your programs more modular and easier to understand. Section 7. Practical applications of CC's speed, efficiency, and low-level capabilities make it suitable for a wide range of applications. For instance, C was used to develop operating systems like Unix, Linux, and Windows. It's ideal for programming microcontrollers and other resource-constrained devices in embedded systems. In game development, C is used in game engines and for developing performance-critical game components. When it comes to database systems, C is used in databases like MySQL and PostgreSQL. Additionally, C is often employed to build compilers and interpreters for other programming languages. These are just a few examples of the vast applications of C in the world of software development. Section 8. The importance of learning C. Learning C provides a strong foundation for any aspiring programmer. It's a language that has stood the test of time and remains relevant even in today's rapidly evolving tech landscape. Here's why. First, C teaches you core programming concepts like memory management, data structures, and algorithms. These are fundamental skills that are applicable across all programming languages and are essential for writing efficient and effective code. Second, it allows you to write highly efficient and optimized code, which is crucial for performance-critical applications. Whether you're developing software for embedded systems, game development, or high-frequency trading, the ability to optimize code can make a significant difference. Third, C gives you fine-grained control over hardware resources, making it suitable for system-level programming. This means you can write code that interacts directly with the hardware, which is essential for developing operating systems, drivers, and other low-level applications. Fourth, many modern languages are based on C, so understanding C makes it easier to learn them. Languages like C++, Java, and even Python have their roots in C, and knowing C can give you a deeper understanding of how these languages work under the hood. And lastly, C programmers are in high demand across various industries. From tech giants to startups, Companies are always on the lookout for skilled C programmers who can tackle complex problems and develop robust solutions. Even if you don't end up using C directly, the skills and knowledge you gain from learning it will be invaluable throughout your programming journey. The discipline and problem-solving abilities you develop will serve you well in any programming language or tech-related field you choose to pursue. Section 9 Conclusion. Your C journey begins. This essay provided a glimpse into the world of C programming. We covered basic syntax, data types, pointers, flow control, functions, and the practical applications of this powerful language. Remember, learning C is a journey, not a sprint. Be patient with yourself, practice regularly, and don't be afraid to make mistakes. As you dive deeper into C, you'll discover its elegance, power, and the endless possibilities it unlocks in the world of software development. Your C journey starts now.